I'm fine, sir.
Okay, let's wait for a few minutes and then we'll start our session. Hello Arnav.
Hi, sir.
Hello Parthiv.
Hi, sir.
Alright, let's start the session now. The first question is on your screen. Try this question. Let me know if you have any problem in understanding it. Anyone with any guess?
Uh, is it B?
No?
Then it's A
Yes,
because it won't change. Yeah, yeah.
exactly. No, C is the wrong answer. The right answer is A.
But as the projectile is moving further, there's a gravitational force acting on it, right? It will pull it down, so speed might get affected.
Yes, the speed will get affected, but in the question it has been asked for the only horizontal speed.
Yeah, that would be the same. Yeah, yeah.
Yes, so only the horizontal component of the speed is to be taken into consideration. So see, suppose the projectile is fired horizontally, alright, with an initial speed of 20 meters per second. And the only force acting over it is the gravity that is acting in the vertical direction. So there is no force in any horizontal direction, so its velocity will remain the same. So A will be the answer. Anyone having any doubts?
No.
All right, let's move on to the next one. Anyone with any answer? Or shall I give you some hints? All right, I'll tell you a few steps. See, in this question, mainly you just have to use the formula and just modify them. All right. So a projectile has the same range R for two angles of projection. So same range R दो अलग angles के लिए कब होती है जब दोनों angles complementary हो. So suppose एक थीटा है और एक 90 माइनस थीटा है. Alright. तो से तो इनके T1 and T2 क्या हो जाएंगे? T1 can be calculated as 2u sin theta by g, right? And T2 will become 2u sin 90 minus theta by g. This can be written as 2u cos theta. Is that right? Now we have to find r. So r is u square sin 2 theta by g. इसको आप थोड़ा सा ओपन करें. So you'll get u 2u square sin theta cos theta by g. अब इसको देखो एंड इसको देखो, इन दोनों को यूज करके क्या हम किसी तरीके से इस पे पहुंच सकते हैं? अब ट्राई करो.
Is it C?
No. Is anyone else trying or shall I proceed with the solution?
It's B.
No. A is also the wrong answer.
It's D, no?
No, it's not D. It's B for Bombay. All right, I'll tell you the solution. See, here you have a sine theta, cos theta, and u square. So why not we try to multiply both of them? So what do we get? T1 into T2, we get 4u square sine theta cos theta by g square. Alright, but we want to make it this. So we can divide it by 2, t1 t2 by 2, and we have a single g over here. So we multiply it by g and a g over here. So this becomes equal to r. Alright, so the answer will be B. See, in the solution, we are just playing around with the formulas. So you just have to keep that in mind that these type of questions also appear. Anyone with any doubts? Or shall we proceed to the next one?
Yeah, we can proceed.
Alright, you have the question on the screen, and I'm giving you 2 to 3
What's muzzle
minutes
speed?
on this one. Yes?
What's muzzle speed?
Muzzle speed is just initial velocity.
Is it air?
No. Anyone else?
It's B.
Yes?
It's B. Bombay.
No.
Oh.
No, B is the wrong answer. Shall I tell you some hints? Alright, I'll solve a few steps for you. Alright, I'll wait. Yes, D is the right answer. Alright, let's proceed. The solution. See, what's given is the range of a gun which fires a shell with muzzle velocity speed v is r. That means the initial velocity is given as v, the range is given as r, then the angle of elevation, that is the theta, is asked. So what do we have the relation for r? We have u square sine 2 theta by g. So u over here is v, so we put v square sine 2 theta by g. I think this question was relatively easier. So we have to find theta, so we just keep removing every other thing from over here. So how do we do that? R by V square into G equals to sine 2 theta, and taking sine inverse on the both sides, and 2 goes over there. So it's the option D. आ गया सबको समझ में?
Yeah.
Shall we move on to the next one? बढ़े आगे?
Huh.
All right. This is a nice question. I'm giving you 3 minutes to solve this one. Yes, C is the right answer. Anyone else? Yes, C is the right answer. All right. See, a stone is thrown with a speed of 20 meter per seconds. That is with an angle of 60 degrees with the ground. So suppose it moves like this. So when it makes an angle of 30 degrees, then its speed is asked. So see, what do we know in this situation is that the horizontal velocity always remains the same. So what's the horizontal velocity in the beginning? We can say it is 20 cos 60. So in this case, in the second case also, the horizontal velocity will remain the same. That is 20 cos 60. Alright, but suppose here the net velocity is u. So it is also u cos 30. Right? So what we can do is we can equate both of them. 20 cos 60 equals to u cos 30. That is, that gives us the option C. आया सबको समझ में? Anyone having any doubts?
No, sir.
All right, shall we move on to the next one?
Yeah, sir.
Okay. Anyone with any answer?
Yeah, I'm calculating. I got
All
it.
right. No one has got any answer till now. क्वेश्चन समझ में आ गया?
Huh. Basically, maximum height is 45 and your range is 180.
Yes, that's right.
So we will take two formulas and then use simultaneous equation to fix it.
Yes, you can use simultaneous equation, but there is an easier method to do that.
Division of two equation.
Yes, you can divide and then it will be much easier. Yes, D is the right answer.
Yeah, even I got D.
All right. See what's happening in this question is a shell fired from the ground is just able to cross in a horizontal direction at the top of a wall. Alright, so there is a wall and the shell is just passed in the horizontal direction. So it must have come somewhere from here. Alright, and it will go towards here. So this will be our complete range. It is given, sorry, it's 90 meters away and 45 meters high. All right. So what do we have? We have the height h, that is u square sine square theta by 2g, that is given as 45. And we also have a range, that is a double of 90, that is 180. That can be written as u square sine 2 theta by g, that is 180. Alright, now we want to find the direction of projection of the shell. That is, we have to find somehow theta. So what we can do, we can simply divide these two equations and u square कट जाएगा, g से g कट जाएगा and sin 2 theta को भी open कर देंगे. So we'll get sin square theta upon 2 and another 2 sin theta cos theta equals to 45 by 180. Alright, so sine cancel. So that will give us, let's directly take this tan theta equals to 1 by 4. That is tan theta equals to 1. That gives us theta equals to 45 degrees. That's the option D. आ गया सबको समझ में?
Yeah.
Alright, let's move on to the next one. सॉल्यूशन किसी को वापस देखना हो तो बता देना. No, A is not the right answer. Anyone else?
Is it D?
No. Alright, I'll help you with the solution. See, the angles are theta and 90 minus theta. So the time of flight is 2u sine theta by g. The speeds are same, so u will remain same for both of them. So let this be t1 and t2 is 2u sine 90 minus theta by g. That is 2u cos theta by g. So ratio of the times of flight, that is t1 upon t2 is 2u sine theta by g upon 2u cos theta upon g. 2u cancelled out, g cancelled out. That leaves us with sine theta upon cos theta. So the ratio of t1 and t2 is sine theta is to cos theta. It is the option C. Anyone with any doubts?
No, sir.
Alright, let me know if we can move ahead.
Yeah, sir.
Alright.
Is it A?
Yes, A is the right answer.
This wasn't even a calculation question.
I know this was just a theoretical question, just a conceptual one, just like we did earlier. Simply, you just have to know that the horizontal component remains same. Anyone else with any other answer? See, when a projection reaches its highest point, it is somewhat over here. Over here, only horizontal component of its velocity exists. The vertical component becomes zero. So in the beginning, it had 3 I cap plus 2 j cap. That means its horizontal was 3 and its vertical was 2. So over here, only 3 will remain. So that gives us the option A. Alright, shall we move ahead?
Yeah, sir.
Okay. This is also a good question. You can take your time to solve this one.
Is it B?
I'm sorry, what?
Is it B?
B for Bombay or Delhi?
Bombay.
Yes, that's the right answer. Yes, B is the right answer. See, we can do this easily using relative motion. Is anyone else taking any time to solve? Or shall I proceed with the solution? Alright, let's see the solution. See, a very broad elevator is going up vertically with a constant acceleration of 2 meter per second square. Alright, at the instant when its velocity is 4 meter per second, a ball is projected from the floor, the left, the speed of 4 meter per second relative to the floor. Alright, at an elevation of 30 degrees. So we need to find the time of flight. Alright, so we can see that velocity we have a relative we have, so we can just take the complete question into relative motion. So चेंज क्या होगा, एक्सेलरेशन चेंज हो जाएगा. तो फॉर्मूला क्या होता है हमारा, 2u sin थीटा बाई जी. u हम रिलेटिव में ही ले रहे हैं तो क्वेश्चन में रिलेटिव ही दिया हुआ है. थीटा विल रिमेन 30 डिग्रीज. जी की जगह हमारा आ जाएगा जी प्लस ए. Alright, so that gives us, sorry, u is 4 and sine 30 upon g can be taken as 10, so 10 plus 2, that gives us 4 upon 12, that is 1 by 3. So B is the right answer. आगे सबको समझ में?
Yeah.
किसी को डाउट है?
No, sir.
Alright, let's move to the next one. क्वेश्चन समझ में आ गया ना?
Huh.
See, you just have to use the equation of projectile in the generalized form. Alright, shall I tell you the solution?
Yeah.
Alright. See, जनरल इक्वेशन क्या होती है? Y equals to x tan theta minus gx square upon 2u square cos square theta. ठीक है, ये इक्वेशन याद रखनी पड़ेगी तुमको. अब इसको बस इससे कंपेयर कर लेंगे. यहाँ पे x के साथ में √3 है, तो यहाँ पे x के साथ में जो tan थीटा है, so tan theta becomes √3, so theta comes 60 degree और pi/3. दैट्स इट, इतना ही करना था इसमें. आ गया सबको समझ में?
हाँ.
डाउट किसी को?
नहीं.
Alright, here's the next question, and this is the last question for today.
It's A.
Yes, A is the right answer. Anyone else? Yes, A is the right answer. See, we have R vector with us. R is the position vector, alright. That is PT I cap plus C T square J cap. And we want to find about the velocity vector. So velocity vector कैसे related with respect to time. Alright. So V vector becomes, इसको टाइम से डिफरेंशिएट करेंगे t के रिस्पेक्ट में, so we'll get b I cap and this becomes c into 2t j cap. Alright, so इसका क्या मीनिंग है कि इसका हॉरिजॉन्टल कंपोनेंट है हमारे पास b एंड एक वर्टिकल कंपोनेंट है हमारे पास 2ct. ऑलराइट, ये वेरिएबल है, ये टाइम के साथ चेंज होगा. So what do we want to find? We want to find the value of t such that the resultant vector जो इसका होगा that should make 45 degrees with both of these axes. So we can simply find the tan theta of the variable vector, that is 2ct upon b, and we have theta is 45, so tan 45 becomes 1. That will be equated to 2ct upon b. That gives us t equals to p by 2c. That is the option A. आ गया सबको समझ में?
Yeah.
All right, that's all for today. Thanks for joining.
Thank you, sir.
Good
Bye.
night, everyone.